there with the county engineer and Commissioner Lewis. Okay, this cement railing that's there, or is that the cement railing?
Well, these are three alternatives for replacing the concrete railing that's there.
Okay, this is on the outside towards the river, and that's the, so what, if that's, is that cement or what is it?
This would be, it's called a two-tube steel rail. It meets current traffic safety standards. And there's some flexibility in how you can shape it and install it. One of the challenges with installing or designing special traffic barriers is that Federal Highway has requirements that says, you literally have to crash a truck into it and observe how it performs. It's called crash testing. So if we were to dream a new traffic barrier up out of thin air, we would have to go through that process, which is time-consuming and pretty expensive.
Oh, yes.
So what we do is we look at alternatives where the ODOT has a suite of rails that have already gone through that process. So you look at rails that are in the current catalog that you can make minor changes to fit your needs, and that's sort of what we have here. This is the ODOT standard version. This is what ODOT would put up on a day-to-day basis to protect pedestrians on the sidewalk. One of the challenges on this bridge is every bridge has to have a crash-worthy rail. The pedestrian rail on our bridge is good for pedestrians. It meets all the pedestrian standards, but it can't resist a vehicle impact. So we need a traffic barrier at the face of the curb. So that's what we're planning to do. The concrete barrier that's there now doesn't meet any kind of current standard. So we're looking to replace it. So this is the sort of day-to-day ODOT standard. This is the least cost alternative, and there actually is a benefit here. It's very, very light. We have an old truss. It wasn't designed for modern loading. So anything we can do to lighten the load on that truss gives us more capacity for vehicles, which is a good thing. This one's very, very light, and it's also it's very inexpensive to maintain. It's inexpensive to begin with, so that saves money that we can apply to other parts of the project. So there really is, even though it's not the prettiest rail, there are some real advantages to it. This is probably what ODOT would normally go with on a bridge like this. And this two-tube rail, here's a little cross-section that gives you an idea of what it looks like. They're individual posts about every 10 or 12 feet with two steel rails, and that's what is exposed to traffic. So if a car hits this rail, it's going to hit these two posts, these two horizontal rails, and that's what you see here. The nice thing about this is, as long as the post has the same strength as the design that was tested, you can kind of play around with it a little bit. You can maybe put a steel tube instead of this kind of shape that you see here. Give it a little bit cleaner look. You can take these and the horizontal rails, and you can bend them down towards the deck, just like the existing concrete rail. The top of the rail kind of curves down to meet the top of the sidewalk. You can do the very same thing with this. So you can start to with a rail that's very light, doesn't overload the bridge. You can start to reintroduce those kind of elements. This one is our concrete alternative. And the challenge with the concrete alternative is it's got to be quite a bit higher than what we have right now, which means it's going to be a little bit heavier. So a little more load on the bridge, which takes away from the vehicle capacity, but this is about as close as we can get to the existing appearance. You'll notice that the rail that's out there now has these nice little radiused openings on the bottom side. We can recreate that sort of look. The only difference is this horizontal rail here is going to be bigger. It's going to have a more substantial look to it. And there really is no good way around that if you're going to meet the modern traffic standards. So this one is a real quandary. We know this is one of the essential elements that needs to get replaced on the bridge. And this is one I'm very interested in seeing what folks think.
So as far as keeping with the aesthetics of what the bridge is, C is probably going to get you here closer.
C is going to get us closer. Yep. There is a trade-off in that it is heavier.
Right.
But this one's definitely going to get us the closest.
Well, at some point in time, I know that as in the city they have talked about, do you put weight restrictions on that bridge at some point in time? And that's one of the things that would probably help change that focus.
It would. We have a goal, and that is we want to try to leave this bridge stout enough to carry modern loads without any load posting. Doesn't mean that you can put really heavy permit loads. If you have a truck that's just so heavy it doesn't fit under a legal load category, maybe it's a 200,000 pound truck or something like that, special load, a crane is a good example. Those kind of vehicles will never go over this bridge. But we want log trucks, your basic day-to-day tractor trailers to be able to go over this bridge.
Is there going to be anything that changes the cornering apex to where you've got ability to turn in and turn away through those corners?
No, not really. We have been watching the trucks that have been using it, and the picture over here gives you a little better idea. The flares on the bridge aren't that bad. You do have some off tracking from vehicles that are heading eastbound and then turning south onto the bridge. But because of the flare, again, it's not too bad. It's okay. The problem has more to do with the narrowness.
Right. Yeah, there's a lady trying to take a photo of her.
Well, it's okay. It's all right.
So we do have a little bit of tracking into the other lane. But apart from, we're married up against buildings on that west side. And we have cost constraint. There's a fixed budget for the project. So it's one of those things that is...
So cornering shouldn't be an issue. What about when you close lane staff? How are you going to address getting people back and forth?
Go take a look at that board over there, and you'll see we're taking maximum advantage of the flares at the end of the bridge.
Okay.
So that helps, and you'll see that drawing shows a hard barrier which protects vehicles from getting into the bridge. That truss is going to have a containment system all around it.
Traffic control plan.
So when they remove the lead, it'll all be under a controlled environment. And so we want a hard barrier that prevents anything from getting in there and hitting that scaffold system that supports that. So we have a hard barrier, and you'll notice that there's little barrels kind of in a nice sort of swooping pattern there. That's a pretty picture. In actuality, the contractor sets it up in a way that functions, right? And those barrels are more there for a visual indicator than anything else. A car can run into them, it doesn't do anybody any damage, right? But they're nice, large obstacles that are reflectorized. So I think we'll be okay. I don't think we'll make the situation any worse. If anything, during construction, it'll be a little bit better because you won't have opposing traffic. You'll only be one-lane traffic.
And how are you going to control the traffic? Are you going to put in temporary lights, or are you going to...
Yeah, let's take a closer look at that board here. So the good thing, the best thing about the way we're attacking the project is we'll always have one lane open for vehicle traffic at one side. So that was kind of a minimum standard that we set, and it's not difficult to do that on a bridge like this.
Sure.
So this gives you an idea. In the first stage, this is what the containment over the truss would look like. It'd be a plastic sort of enclosure supported by a scaffold system, and it'd have positive air pressure, so stuff couldn't escape through any seams or cracks or anything like that. And then we have a full width lane here with a full sidewalk, and you can see we're pretty much getting the full width that a vehicle would, at least the width that a vehicle has right now to make those corners.
Okay. So where it's coming off the corner here, if they're trying to go from west to south, a larger truck, you're not going to have a problem moving the vehicle.
That's right.
It's going to give them enough room for swing.
Right.
Okay.
It'll give them all the room that they have right now, and there won't be any vehicles in the oncoming lane that
Right. So
get
there's
away.
no, the opposition isn't there that they might run into.
That's right.